Hello everybody, welcome to Math JCH. For this video, we're going to evaluate the following roots. We have, for example, a square root of 49, a square root of negative 36, cube root of 125, cube root of negative 64, and we also have some decimals that we're going to work on. The square root of 0.04, or the cube root of negative 0.027, and also a cube root of a fraction as well. So we're gonna go through each one of them. So let's start with a square root of 49. How do we simplify or evaluate this root? Well, it is very important for you to practice the multiplication table. As you might know, 49, we could rewrite it as 7 times 7. Now, if you multiply the same number twice by itself, we could also rewrite it as 7 power 2, which means the same thing. 7 times 7, we could rewrite it as 7 with power 2. Also, it is really important to know that when this number here is called the index, is not given, automatically it's index of 2. When the index of 2 and the exponent of the number inside the root is the same, they will basically just cancel. So my answer will be 7. Or we could say the square root of 49, as you might know already, will be 7, because 7 multiplied by 7 will give us 49. For the next problem, we have the square root of a negative number now. For this problem, it's important to know that a definition that a square root of negative 1 is equals to an imaginary number. That means that negative 36, I could rewrite it as negative 1 multiplied by 36. Now, since they both multiply inside that root, I could separate them into each one having its own root. So I'm going to have a square root of negative 1 times a square root of 36. Now notice, we have a square root of negative 1 here. That means that we could substitute it with the letter I, which means imaginary number. So that will be I times, now the square root of 36, as you might know, it will be 6. But why? Because 36, I could rewrite it as 6 times 6. And 6 times 6, I could also rewrite it as 6 with the power of 2. And as mentioned before, if the index is not given, the index automatically will be 2. Now, if the index is the same as the exponent, they automatically will cancel. And I'm left with I multiplied by 6, which will give me I times 6, that will give me 6I. And that will be the solution for this problem. For problem number 3, we have a cube root of 125. In this one, the index is given, which is a 3. So how do we evaluate this root right here? The step to evaluate is to do the prime factorization of whatever number is inside the root. So 125, we could do the prime factorization here on the side. Notice that it's n times 5, so it has to be a factor of 5. So which number times 5 gives me 125? It happens that 5 times 25 will give me 125. Next in 25, we can further do the factorization of that, which is going to be 5 times 5, and then bring the other 5. Notice that we have a cube root here. So basically, we're looking for a number that we could be raised into the same index right here. In this case, we have 5 times 5 times 5. We could rewrite it as 5 to the power of 3. So that's what we're looking there. Some number to the power of 3 because our index is 3 as well. So 125, I could rewrite it as 5 to the power of 3 because that will give me 5 times 5 times 5, which in fact is 125. Now, same index, same exponents, they cancel, and I'm left with only 5 without the root already because the root is being canceled with the exponents here. So that will be my solution. For our next problem, we have cube root of a negative number. Notice that in this case, we have a cube root. So we could actually have a negative number inside the root. So we're not going to use the imaginary I, okay? Because our index in this case is an odd number. So use this I only when the index is an even number, like 2, 4, or 6, or even 8. But in this case, we have an odd number like 3 or 5 or 7, so we don't have to use the I. That means that it's okay to have a negative number inside the root. Now, let's do the factorization of negative 64, okay? So we have negative 64, you know, is negative a times a, because remember, negative times positive, it's a negative. So negative 8 times positive 8 gives me negative 64. Negative 8, I could rewrite it as negative 4 times 2, and then 8, I could rewrite it as 4 times 2. But notice here, we have an index of 3. So that means that I'm looking for a number raised to a power of 3. Which number is going to be that one? Now, since this one is negative, my number inside has to be negative as well. That's one trick that you could use. Here, right, I have negative 4 here, and I have 4 there, right? So I have 2 4s. And then these two, and then these two could make out a 4, right? So I'm going to have 3 4s actually, right? So I'm going to have negative 4 times 4. Then the other 4 will come from the multiplication of this. That 2 times that 2 will give me 4. So again, right, negative 4 times 4 is negative 16. Times 4 gives me negative 64. So the number that is going to go here inside is going to be actually negative 4. Because negative 4 to the power of 3 is going to be negative 4, right? Times negative 4 times negative 4. I could use parentheses if you like. And negative 4 times negative 4, this gives me positive 16. Times negative 4, positive times negative, gives me negative 64. So, the cube root of negative 64, I could rewrite it as negative 4 to the power of 3. And again, power of 3 and index 3, they will cancel out, and I'm left out with negative 4. For this problem, we have a square root of 25 divided by 4. So we have a fraction inside the root. Notice that for this problem, the index was not given. So automatically, our index is going to be a number 2, which makes it a square root. Now, when we have this type of root, what we want to do is that we want to split each number with its own square root, because everything is inside the square root. So we could separate them into each one having its own square root. So, as you might know, the 25 and each one having a as index of 2, okay? So 25, I could rewrite it as 5 times 5. And the 4, I could rewrite it as 2 times 2. And again, 5 times 5, another way of rewriting 5 times 5 is going to be 5 to the power of 2. And 2 times 2 again, same principle. could rewrite it as 2 to the power of 2. Why? Because 5 power 2 gives me 25, and 2 power 2 gives me 4. And again, same index, same exponent, they will cancel. So in the numerator, I'm left out with 5. And in the denominator, again, same thing. The 2 cancels, exponent and index, and I'm left out with number 2. And that's going to be my final solution, because 5 and the 2 you cannot simplify. 5 is not a factor of 2, and vice versa. For problem number 6, or F, we have a square root of a decimal number now. We have 0.04. Now, how do we approach this problem? One approach is going to be to convert the decimal number into a fraction. Okay, so let's do that first. So let's convert a decimal number to a fraction. Okay. Okay, so the numbers that are always used to convert a decimal to a fractions are the following: 10, 100, 1,000, and so on. It could be 10,000, it could be 100,000. Depends on how many numbers after the decimal point we have. Now, if the decimal number has one number after the decimal, we're gonna use the 10. If it has two, we're gonna use 100, and so on. Notice in our problem we have 0.04. How many numbers after the decimal point do we have? We have 1 and 2. That means that we're gonna use 100. One trick that you could use is 100 has 2 zeros, and our number has 2 numbers after the decimal point. So let's do that. So 0.04, we could rewrite it as, so write the number without the zeros in front and at the end. So that means that before divided by whichever number from this we picked. So that will be 100. Again, rewrite the number without the decimal point and the zeros in front. So that will be 4, right? But if you go this way, our first number besides 0 is gonna be 4. And there is nothing left after, right? So that will be 4 divided by whatever number we choose here, which is 100, because again, we have 2 numbers after the decimal, 1 and 2. Now, the fraction of our decimal number is going to be 4 divided by 100. Now, let's rewrite square root of 0.04 as 4 divided by 100. Again, this is very similar to our previous problems in which we have a fraction. And again, if the index is not given, automatically it's going to be 2. That means that for every number, we're looking for some number to the power 2. But first, let's separate our fraction into each one having its own square root. That means that we're going to have a square root of 4 divided by square root of 100. Each one having its own root, since everything inside falls into the same square root. Now 4, as in the previous problems, we have found out that we could rewrite 4 as 2 to the power 2. Because 2 to the power 2 means 2 multiplied by itself twice, which gives us 4. And 100, we could rewrite 100 as 10 times 10. Now notice, let me rewrite the top without simplifying. Now, the 10 times 10, we could rewrite it as 10 to the power 2. Now notice what's going to happen. The index 2 and the power 2 will cancel, and I'm going to left with number 2. And here the same, the 2 and the 2 cancels, index and exponent, and I'm left out with number 10. Now, this is supposed to be my answer. Yes, but not our final answer. We still have to see if we could simplify the numbers. That 2 and the 10, I could both divide them by 2. Remember, in order to simplify or to reduce a fraction, we have to divide each number by the same number. If I divide this by 2, I have to divide this by 2 as well. So I'm going to have that 2 divided by 2 gives me 1, and 10 divided by 2 gives me 5. And that's going to be the final answer. For our next problem, we have a cube root of a negative decimal, negative 0.027. Again, our index is an odd number, so it is okay to have a negative number inside a radical. So we need to convert the decimal number into a fraction in order to make a simple approach to evaluate the root. Again, the first thing that we do is to count how many numbers after the decimal we have. We have 1, 2, and 3. That means that we need to use the number 1000 because 1000 has 3 zeros. So again, 3 zeros and 3 decimal numbers. Therefore, we could rewrite negative 0.027 as follows. The negative, we could leave it there for now. It's not going to hurt anything. Again, rewrite the number in the numerator without zeros in front. So we have number of 27 divided by the number that we're going to use, which is 1000. Because 1000 again has 3 zeros and 0.027 has 3 numbers after the decimal. Now, the next step that we could do is to separate each one into its own cube root. So we could rewrite, and again, since we have only one negative here, this negative, it only could be given into one of these numbers, either the 27 or 1000. Let's give it to 27 for now. So I'm going to have negative 27. Now, since the negative is given to the 27, now the 1000 stay as positive. Now it's simpler to simplify this root or to evaluate this root. Our index in this case is 3 for each number. That means that we're looking for some number to the power 3 that gives me negative 27. And also some number to the power 3 that gives me 1000. Now, negative 27, we could rewrite it as 9 times 3. But notice that I need a negative, so I could put it here on the front. And 1000, I could rewrite it as 100 times 10. Now, negative 9, notice that my index is 3, so I need some number to the power 3. So from 9, I'm going to get the other numbers that I need, which is going to be negative 3 times 3, and then bring down the 3, this 3 right here. And then 100, I could rewrite it as 10 times 10 and bring the 10 that is left there. Now I have negative 3 times 3 times 3 will give me negative 27, okay? But the way to write it this is as follows. Is as negative 3 power 3, okay? That's how you rewrite it that, because negative 3 to the power 3 means negative 3 times negative 3 times negative 3. And negative 3 times negative 3 is 9. Bring down the negative 3, that will give me negative 27. And that's what I want here. So negative 27, I could rewrite it as negative 3 power 3. And 1000, notice that I have the 10 multiplied by itself 3 times. So I could rewrite it as 10 to the power of 3. Right? So that's going to be 10 power 3 gives me 1000. Now, next, same index, same exponent, boom, cancel. I'm left out with negative 3. And this 3 with this exponent 3 is gone, and I'm left out with 10. And since we cannot simplify because 3 is not a factor of 10, and 10 is not a factor of 3, then that's going to be my final solution. For our next problem, we have fourth root of 625. And the negative is actually outside. So we don't have to worry about the negative until the end, okay? All we have to do is to carry it along with us. So we have 625 to the index of 4. How do we approach this problem? Let's first do the prime factorization of 625. Okay, so let's do it here on the side. So 625. One number times one number gives me 625. Notice that it ends in 5. And it happens that 25 times 25 gives me 625. Now let's break it down that each 25 again. 25, as you might know, is 5 times 5, and then 25 is also 5 times 5. So 625, I could rewrite it as 5 times 5 times 5 times 5. In other words, I could rewrite it as 5 to the power 4. So could rewrite it as, again, bring that negative down. 625, rewrite it as 5 to the power 4. Again, we have index of 4, an exponent of 4, boom, go away, and I'm left out with that negative and then the number that is inside the radical. And that's going to be our final answer. For our final problem, we have a cubic root of a fraction again, of 27 divided by 8. Again, let's do the prime factorization of each number. But before doing that, let's break down each one into having its own cubic root. So we're going to have cube root of 27 divided by a cube root of 8. Now we can do the prime factorization of each one. So 27, as we may know, is 9 and 3. And 9, we could further break it down as 3 times 3 and bring down the 3 from the first step. So 27 is basically 3 times 3 times 3, which is 3 to the power of 3. Now let's break it down 8. Let's do it here. 8 is 4 times 2. And 4, we could break it down as 2 times 2. Bring down that 2 from the first step. And so we have 2 times 2 times 2, which we could rewrite it as 2 power 3. So each number has an exponent of 3, which is the same as the index. Therefore, 27 is 3 power 3, and 8 is 2 power 3. As you might anticipate, this 3 index 3 and exponent 3 cancel, so I'm left with only 3 without the root already because it cancels. And same thing happened in the denominator, so I'm left out with 2. And 3 and 2, you cannot simplify it because they're no factor of each other, so that's going to be our final answer.